So, welcome to my talk, Fun with JSON, which is the first of 4 little talks that I'm going to give. So, if you kind of want to walk out after 1 or 2, then I don't mind. But I'm going to start off with a little kind of a brief question. Who knows what JSON is? Does anyone not know what JSON is? Nobody in the room. Okay, so that's kind of the first talk over. But it's kind of my point that everybody knows what JSON is, which is, it just means that it's an incredibly important syntax that we can learn and we can interoperate with. These are my cats. In Juxt, even our cats have 4-letter names, and this is the JSON representation of my cats. So this is 2 cats, one's Aria, one's Kaya, and I've got a little JSON document with 2 objects, or JSON calls them objects, so 2 maps. And if you squint very carefully, it kind of looks like Clojure. And it's so close to Clojure, I think we should be using JSON as our external data representation, full stop. And kind of, well, anyway, here's another piece of JSON. Again, this is actually called JSON Schema. Has anybody heard of JSON Schema? It's pretty popular. Tommy did say in his talk that I was going to talk about it. I'm going to give a quick introduction to JSON Schema. So this is a document that says that valid documents to this schema have to be maps or objects. And there's 2 properties. One's a name and one's a tag, which is what we had before. But the name is required. And JSON Schema is actually very interesting because it's very, very extensible and it's very powerful. This is an example of a JSON schema that is using inheritance. So there's 2 things I want to point out here. The first is that there is a reference to another schema, which we're going to call new pet. And this new pet is just going to be the name and the tag. But now we're going to add to it another constraint. And this is a required extra property called ID, which is a string, which is going to have a regex. So we've kind of created a subtype there. And we do that with this all-of keyword. And JSON Schema has been around for a long time. I think it's been around for about 8 years, but it's still in draft. It's coming close to finishing, I think. And I think there's a race on between Rich Hickey and the JSON Schema people. Are the JSON Schema people going to come out of draft faster than Rich Hickey comes out of clojure.spec alpha? Well, who knows? But I am quite glad that they're spending so long working on JSON Schema because it's actually a really, really nice spec. I tried to implement it last summer, and I really learned to appreciate how much thought had gone into it. Essentially, JSON Schema is just a set of lots of little annotations and assertions that are all independent and extensible. You can throw in your own. If you want to have a new kind of metadata type, you can add to it. And it was super easy, really, to implement. So I had a little go last summer, which I'll show you later on. JSON Schema is almost a complete meta model. You can use it, but it is a data format. I think this is something that's this is a point Tommy made about Mali this morning, that it's a really important thing to be able to treat our metadata as data, to be able to manipulate it, transform it, and generate it. JSON Schema, though, unlike Mali, is super interoperable. Every language supports, has kind of validators for certainly for JSON and JSON Schema. So I think it is the thing that we should embrace because it's so like Clojure, so like Eden. It's actually a miraculous thing that the world has arrived at this format, which is a nested set of lists and maps of lists and lists of maps. I mean, who would have guessed that non-Lisp people in the JavaScript world would have arrived at something that was so Lispy. And it actually plays to our advantage. We've got this amazing language, which I like to call JSONScript. Some of you know it as Clojure. That is really good at manipulating these documents. So why are we still using Eden? And I think it's a really important thing that we interoperate with the rest of the ecosystem. JSON Schema is really, really powerful. Tommy mentioned today about he spent something like 75 years of his career creating UI forms from different technologies, and how the ability to define a UI form in data and have the UI generate is a really powerful thing. There's so much code that's written, and we have some code in Jux which is just the same, where a new field needs to be added, and you go in and you change the closure code, and you recompile, and you go through continuous integration. And it's so brittle, it's so inflexible, because the domain model changes all the time. Businesses change with different market conditions. They're always changing what they need. And so we need to make our code more flexible. I was introduced to this thing about a year ago, which is, it's a React component. And what it does is it's called React JSON Schema form. And it's a React component that takes in a JSON Schema definition. And here it is. If I just and it kind of allows you, so you may not be able to see, some of you at the front will be able to see this, but I can change the JSON Schema definition, and you can see over here that the title has changed. And I can put in perhaps a phone number, and the UI is generating, should not be shorter than 10 characters. Well, maybe we want to change that validation to 12 characters. So here we are, we can go in here, I can set the min length of the telephone number, let's set it to 12, and now it's going to let me have 12 characters, and it's changed the error message. And this is done all through data, there's no kind of special code for this. And I think this is really what we as Lisp programmers should be doing, creating little interpreters and little compilers that take an input language and behave accordingly. So now this is a component written by Mozilla Labs, and when I looked at the quality of this, at the actual code, it is kind of a labs quality component. There's lots and lots of issues with it, and it's built on a JSON Schema engine called AJV, which is very, very fast. But when I started using it, I realized that it was all kind of mutable data structures, and the whole thing was kind of crying out for being written in Clojure. So I thought, well, if we wanted to create things like this and exploit JSON Schema, I really need to find a nice wrapper for Clojure so I can use it. I tried a few different Java versions and ended up kind of getting into that object hierarchy hell and Java interrupt. So I wrote I attempted to write a JSON Schema library called Jinx. And I was able to complete it and pass all of the tests in the official test suite, which is really nice if you ever have a chance to write a piece of code against a test suite that somebody else has written. It's really nice, and I learned a lot about JSON Schema as a result. So I called this one Jinx. Jinx is a recursive acronym. Means Jinx is not XML schema, because it's JSON Schema. So I'll give you a bit of a demo. So this is the cat. And what I wanted is to be able to validate, this is the document, and this is the JSON Schema. Notice I'm using strings rather than keywords, because I don't really want to go into all the kind of changing strings into keywords and the hyphens and things. It's fine using strings in the key, Clojure works with it. You can even destructure. So some of you might think, oh, there's no keywords, I can't see, but just, you get used to it. Yeah. So this is a cat, and what I wanted as a result of this is a report, so that when I validate this, I can see, right, Luna is a cat, and that's valid. Well, what if we took Luna's name out, because the name is the required key, and now we're getting one or more required properties not found in object. Now this doesn't have the human eyes and the kind of message explain. It's just kind of I guess a bit more than a toy project. But it does work in Clojure and ClojureScript, and it is the component that I've begun to build on. So at least have something here. You can do other things, like you can say, right, let's give the name a default. So let's do give What's a good name for a cat?
Spot.
Spot. Okay.
It has 4 letters?
Yeah. Great. And now it's valid. So even though we didn't specify here, we've still got the original document. And this was kind of what was nasty about AJV, because in the JavaScript version, JSON compiler, it was kind of mutating the original document. And I don't want that to happen. I want the original document, but I want a potentially validating document to fall out of it. So that's Jinx. Okay. So then, part 2, this is the second talk. I thought, well, I've got Jinx now, what can I do with it? And I remember, oh yeah, there was that Swagger thing a million years ago that used to use JSON Schema to code up parameters. And I thought, okay, I wonder whether it's still using that. And it turns out that OpenAPI did use a very early draft of JSON Schema. Remember, JSON Schema has been around for 8 years. And they diverged. And that was a kind of a shame, because the new JSON Schema is really nice. But recently, they've begun to converge again in the last few releases, until we've now got a situation. I was reading this blog by Phil Sturgeon, who's been campaigning to get this convergence happening. And he's announced earlier this month that OpenAPI version 3.1, which is the next one, is going to be fully converged on draft 8 of JSON Schema. So the idea is when JSON Schema comes out, it's going to be completely the same as OpenAPI 3.1, which means you can just lift up your JSON schemas, put them into an OpenAPI document, and hey presto, it will all work. And you'll get all of the ecosystem of OpenAPI. What is OpenAPI? So OpenAPI is a JSON document that it was formerly called Swagger, and we generate, typically, and I wrote something called Yada a few years ago that generates Swagger. Metosin have libraries that do the same. But I was looking at some Google videos, and I discovered that a lot of people using Swagger were actually using it as an interface contract document, putting it into GitHub, having meetings about it, discussing it, getting the details right, and before they were implementing it. So they were going the other way around, which isn't a new idea. It was a new idea for me, but Tobias Sanowski, I don't know, is Zalando, I don't know if anyone knows him, but he kind of introduced this Swagger first idea in Zalando, and I was reading some blogs about Zalando, and this is the way that they write APIs. And it does make sense, because if there's one part of your API you want not to change, it's the contract. By all means, change the implementation and the code, but you want the contract to stay the same, right? Because if you change it, you're going to affect and impact all of your consumers. So if you're going to get one thing right, it should be the contract. So this makes sense to me. So instead of generating Swagger, I thought, well, what if we just take the Swagger as it is, take the OpenAPI contract, and this is in YAML, but YAML translates to JSON, so the talk's still about JSON. So we can take some data and define some parameter contracts. And this is the example inside the OpenAPI demo called findPets, and it takes name, tags, which is a query, and a limit, which is going to be an integer. So the tags can be an array of strings. And in the OpenAPI specification, you can see there's a vast number of combinations that they support. So if you look down here, if we've got to pass through some tags, we can choose to do it with form space delimited, pipe delimited. We can put them in multiple query parameters. So we could say, right, if I have 2 query parameters called tags, then I want you to combine those values into an array and potentially cast them to integers. So this is really nice, and it gets kind of, they've spent a lot of time making this work. I wanted to write a little piece of Ring middleware that would use this definition and then built on Jinx, and it would just work. So that's kind of what I did. So this is the implementation of the code. So I can get, I have a bit of Ring middleware that puts Apex parameters into the request, and I can say, well, it's in the query string, this is the name of the query variable, and get the value out. If you remember, Jinx is giving me a validation report. So I might say, well, if it's not valid, I want to return a 400. Might make that determination here in the code. So I want to know whether the query parameter is actually valid. I might be being attacked or something. So I've got the choice to do that. And if, in this case, I'm not checking whether it's valid, I'm just getting the value. And then I'm responding, I'm saying, well, get my pets out the database. If the tags have been specified, then I want to filter based on the tags. And if the limit has been specified, I want to take from that sequence. And notice there's no string to integer kind of conversion going on here. All of this is automatic because I've specified it in the contract. So here's some demos. This is find pets. This is adding a limit, so I'm only getting 2 pets here. This is just going to get all of the cats, and this is going to get the cats and the dogs. And notice here we're specifying 2 query parameters because we've, by default, that's what happens. They get merged into an array. So there's a lot of value in that. And there's a huge amount of value in there's the website called OpenAPI.Tools that I wanted to show you, which is this vast ecosystem of it's like documentation generators, text editors, and interestingly, I find these mock servers. These are, once you've written your OpenAPI definition, you can just run one of these mock servers that just comes up, looks at the OpenAPI, and kind of is something that you can then deploy, and then your customers can start working on their clients. I think this is a really interesting idea. The mock servers just generate data, but I'm interested in this Python one called connection, because what this connection seems to do is allow you to get your service up and running and then make changes to the handlers and sort of evolve it. So what I wanted to build is something that would do the same, get up and running straight away, but be able to go from an OpenAPI definition to the very next day having something that works, and then very rapidly add some ring handlers and fill out the implementation. And I think that would be a really, really nice way of writing APIs. You're guaranteed that they're consistent with the definition. You're not having to handcraft or hand code it from the contract, which may well be moving. So I think it's a really nice idea to just generate it from the contract. So here's some examples of what I've got today. So this is a thing called redoc. It takes an OpenAPI document, and this is just taken my OpenAPI and generated some nice documentation. So if you've all ever have the job of writing documentation, you can put descriptions and examples in the contract and then get documentation for free. Okay, we'll go back. We'll click on, this is what Swagger looks like now. It still exists. This is 3.0, and you can we can go into pets. We can deploy this, and you may have seen this. So let's put 3 in there. We'll execute. And we get our 3 pets here. So this is all the stuff that you get for free. Okay, any questions on OpenAPI? Okay, I'll move on to talk 3, which is about authentication. Now this is something that I couldn't believe you could make data-driven. If you've ever written authentication on a web app and OAuth 2 and all that kind of stuff, it's just lots and lots of code. It's a real minefield doing this stuff. There's so many RFCs, so many little vulnerabilities that you have to avoid. This is a great kind of little diagram. The attribution's on the bottom of the slide, and it doesn't appear, so I'll put that in later. Here are some of the things that you have to do if you want to use what's called the token grant flow, if you want to get an access token. So first off, you have to set some session state into your into your session, you do cookie. Then you have to send the browser back to, off to another thing called an authorization endpoint. Then you get a redirect back to yourself with a state and code. So you have to check the state is the same as the state that you created in your session. That's to stop CSRF vulnerabilities. Then you've got this code and you have to send it over HTTP and exchange it for an access token, perhaps over HTTPS, and handle any errors with that. Then if you do get an access token back, you have to verify it. And how you verify it, you need to verify it with a certificate. Where do you get the certificate from? Over HTTPS again. You have to download the key, verify. And there's a lot of work to do this. And I don't. It would be really useful to have all this stuff done for you in a library. You have to verify the integrity, then you have to save the access token, and onwards and onwards. But turns out there's a thing called OpenAPI Connect Discovery. This is another set of JSON documents, and I'll show you one because I'm running Keycloak on my local machine. The rest are kind of online, but all of these work. So this is what it looks like. Some more JSON. So here we have authorization endpoint, where I get my tokens from. This is where we can get the certificates from. Okay, so that's nice. All of the token grant types supported and so on. So what OpenAPI allows you to do is just set the URI of this document, and then the system's meant to just make it work, and it's meant to be magic. And I'll show you the Keycloak. Well, they all work, so let me just give you a quick demo of that. So I built a little piece of Ring middleware that does this. It uses the built-in JDK crypto because I didn't want to have too many dependencies. So the JDK has some nice cryptographic algorithms that you can use natively, and I'm using this Nimbus Java library to do that. And I'm also, for the bit where you have to exchange the token, the code for the token, I'm using an asynchronous HTTP client in JDK 11. So here's the demo. This is what Keycloak looks like. Okay, I'll log in. I'll log in as the admin. So I have some users. This is me. I've set up my user, so I'm going to log out of the admin. I'm going to go to my demo. So this is my code that is using this piece of middleware. And I'm going to call login. Yay, it worked. So this has redirected me back, and the server has done the code exchange and got some information about me. So first of all, it's got my ID token, which is my name. This is the OpenID Connect protocol that allows you to get identification information out of OAuth 2. I've got me, this is my subject, this is who I am, from Keycloak's point of view. And I've got, even down here on the access token, I've got a custom scope called pets_read. So the thing is that demo can if I want to and run this same demo with another provider, this is an Aero document, I can just change this to my other provider and it just works. Don't have to make any code changes. I can change authorization provider to Google, to OneLogin, to Auth0. And I think it's an incredible use of data that I've not had to write any custom code, and I've been able to switch authorization providers. So there must be something very special about coding against data. Okay, so this is talk 4. There's a little retrospective on a library that I wrote about 5 years ago and been maintaining since, called Yada. It's still one of the kind of go-to libraries if you write production code, partly because it was the design goals of Yada was to be a very conformant version of an HTTP web library. There was a library at the time called Liberator that I was helping Philip Meyer work on, and that had the same goals, but I really wanted a kind of an async liberator, and that's where Yada came from, with Swagger support, and we used prismatic schema for the parameters. Now, what I learned from doing Yada is that if you want to write an HTTP conformant library, you need the ring request, you need to work on the ring request, but you also need more information than that, and that's the information about the resource itself that you're serving. And the problem, I would argue, with ring is it only gives you half the story. It only gives you the request, and you have to puzzle out in your own code whether whether your resource should be caching, if so, for how long, what text, what media types that document should produce, what status codes need to be produced. And there's a whole load of things that, the security domain that resource is in, whether it belongs to the user and so on. So I think that the way to write a conformant library is to have two pieces of information, which is the request and the resource. Unfortunately, OpenAPI, Yada had its resource model. If you've written Yada, you may have seen this, which is just a map where you're specifying the methods. This is a get method that has some parameters. It produces JSON, and there's the response. But compared to OpenAPI is doing the same thing. And when I kind of compared the two, Yada didn't look very good. Like, maintainer is me versus the Linux Foundation. I also like the fact that they put their information in a separate document, whereas in my code, I have Yada maps almost everywhere, and they're inside the code. I can't access them. I certainly can't generate documentation. There's a slight difference. The Yada used to negotiate Yada does negotiate the media type before it determines the status, whereas OpenAPI does it after it determines the status. And the difference is sometimes you want to say, on a 500, I want to just return JSON, but on a 200, I want to negotiate between HTML and JSON. So it's good to know what the status code is going to be before you negotiate. I got that wrong in the design of Yada, so I think the OpenAPI people have got that right. And then there's the ecosystem. Another problem with Yada is that it had couldn't use Ring because Ring wasn't asynchronous at the time. So it had a very kind of closed ecosystem. You couldn't just pick up any Ring middleware and make it work with Yada. Some of the downsides is, even though Aleph is a really, really good web server, you're tied to Aleph with Yada, and it means that you can't use Yada in places like banks and things where they need J2EE web servers to interoperate. Also with Manifold was incompatible with Ring. Debugging was hard. When things went wrong, you had no real way of finding out. You had to put a load of print lines in. I found that difficult. And there was a lot of rigidity. It did have support for HTTP security headers, but if you wanted to change those headers or do something a little bit off-piste, you had to look at the documentation, and it was just hard to figure out. It wasn't like Ring where you can just return headers in the map. And it had a really out-of-date Swagger, so like 1.0.1 or something, so it wasn't able to keep up to date. Since I wrote Yada, Ring kind of has started getting support for async, which is really interesting. So I just wanted to explain a little bit about what's happening, because there's a bit of confusion over whether Ring is synchronous or asynchronous. Well, the first versions up to 1.5 of Ring had this design where the request thread would be blocked. If you wanted to do anything like go off to another HTTP server or service, you would be blocking the request thread. And that would be blocked for the whole interaction until you'd got your request body, and then you would stream it, and that would still block the request thread. So what James has done, and what they've done in 1.6 and to 1.8, is that you now have this model where there is an extra arity form in your Ring handlers. So instead of just having one with the request, you can have one with the request and two callbacks, one for the response and one for any errors. And so this allows you to not block the request thread, and that's what I've built Apex on. And then more recently, I think last night, it was announced that Ring 2.0 is going to then address this prevailing problem where once you've got the response body, which may be a video or maybe something quite large, if your client, which could be a mobile phone, stops reading it in the rate that you can produce it, you're blocking the request thread. So Ring 2.0 is fixing this problem in an incompatible way to Ring, but it allows us to be full async. So at the moment it's partially async, which is good, but I'm looking forward to converting this middleware to be kind of Ring 2.0 and having all the benefits of asynchronous Aleph, but for all of the web servers that work with Ring. I've got this kind of, I decided not to move Yada because there's a lot of Jux projects and a lot of other projects that are based on it, and I didn't want to kind of break any compatibility, and it was very, very hard to move it. So I've just decided I'm going to carry on supporting, maintaining Yada, but I'm not going to radically change it. So I wanted to do that in Apex. So Apex is the new Yada, but it's experimental. But it works with Reitit, so there's no biddy anymore. I've adopted Reitit for all kinds of reasons I won't go into. And it does OpenAPI and, at the moment, Authentication. So I've released it today at clojureD in Berlin. As you can see, it has no stars at all. So it's all independent middleware. These are all proper Ring compliant middleware that gets configured independently. You don't need to buy into the whole OpenAPI. You can just take the little snippet. So you can take the parameter bit without the authentication bit and so on. And that's what Apex will do. And then the roadmap it will have, I'll be writing middleware where I need to. You can take other Ring middleware that exists, but where I decide that actually I need some resource information, like for caching and conditional requests, I'll provide that in Apex. So Apex is currently a suite of independent modules that will deploy independently to clojars, but they'll all kind of work together. Now, just a quick word of Crux. I'm really interested in this idea that that schema is just data. Because if you remember Tommy's example this morning about he had a restaurant database, and he was saying that one of his constraints that he was collecting stars. So for the restaurant last night, he said, well, that's 3 stars, and he made the stars optional. And we were discussing this today. Oh, I've got 2 more minutes. This is my last slide. And I think the problem is if you've made a declaration that stars are optional, and then you decide to change your mind, perhaps you're creating some kind of like restaurant guide or something and you need the stars, you might change that metadata, you might change that schema to say now the stars are required. Well, what happens to all of the previous restaurants that haven't got a star? Do you give them all 1 star? Do you do a whole migration, or what do you do? Because they're now all invalid. So I think this is an example of where your metadata and your constraint, your schema documents, need to be made on the timeline. You need to put them into a timeline so that your applications can then know when was this constraint live. So all of the restaurants that you've collected data up until that point, you can say it's fine not to have a star, but subsequent restaurants need to have a star or they're invalid. And so rather than just having one metadata at one point for all time, I think that actually the bitemporality characteristics of Crux and the fact it's schemaless is very important. So I'm looking forward to a point where we add schema onto Crux with little lenses where we can put in the constraints at certain points in time and allow you to then have a very much kind of richer metadata model in the database. That's me. One last kind of plug. Jux do a conference every 4 years. This is a leap year, so we're going to do another one. It's in the summer. We've got Alan Kay, who's a Xerox PARC inventor of Smalltalk and user interface, and coming to speak. And it's going to be a lot of fun, lots of music and dancing and skits and things, and you're all very, very welcome to come. So thanks very much, and that's me done.
Thank you. I've heard the applause downstairs already, so I would ask you to keep the questions until later and then maybe reach out to Malcolm directly. JSON D is over. Let's head downstairs to the rest of clojureD.
Thank you.